session we'll be discussing Bayesian belief network. Basically, there's a difference between a navy Bayes algorithm and Bayesian belief network. The basic difference is the navy Bayes actually assumes that no features are dependent on each other, which means each and every feature which is given in your training data set is actually independent of each other. And that's how the assumption will be made in navy Bayes algorithm. But in case of Bayesian belief network, we'll be considering all the features and we believe that there will be some kind of dependencies between different algorithms. See, for instance, if you are late to the class, right, and waking up late and getting ready late, coming to the class late due to traffic, all these are dependent on each other, right? If you won't wake up late, you will not be late for the class. So this is how the features will be correlated with each other. So we believe that they are dependent on each other in one or some other way. That's what the assumption is made in Bayesian belief networks. But in case of navy Bayes algorithm, we consider each and every feature as independent features, which means all the features are having equal probability for the occurrence of the particular action or the particular event. So that is the basic difference between a navy Bayes and Bayesian belief network. So Bayesian belief network is basically a probabilistic graphical model that helps us to explore the conditional dependencies between different variables or the features which is given in your training data set through a directed acyclic graph. The most important thing is it should not have a loop. So that's what a Bayesian belief network is. So here we have given a graph that consists of rain, windy, cloudy, wet grass, take off from work. So here, since we have said that each and every feature is dependent on some other features, so we have to consider the dependency. That's why we have a table called CPT. CPT is nothing but a conditional probability table, right? CPT. So each and every variable, each and every feature in the graph will have a conditional probability table. That's what we have written, a single table under each and every feature. See, windy is one feature, cloudy is one feature, wet grass is one feature, take off from work is another feature, rain is a separate feature. We assume that each and every feature is dependent on some other variable, so we have to explore it. That's why we are drawing a conditional probability table. Here, windy is a node according to this graph, and conditional probability table is drawn for windy, right? P of W, probability of windy is 0.001. This is an assumption probability which is given based on the training data set. So which means it is true. If it is not windy, then how we can calculate this? We can make it as 1 minus 0.001, right? And now this windy doesn't depends on any other variable, since this is the only node which we have. It directly points to the other node and no other nodes are pointing to windy, so windy doesn't depend on any other nodes. So in that case we will take probability of windy alone. And here it is cloudy. Cloudy is also a separate node which consists of the feature cloudy. It doesn't have any parent node, so we can take only probability of cloudy. For true condition, if the probability of cloudy is yes, then the probability is 0.002. If it is false, I will take it as 1 minus 0.002. That is the value of the false condition for cloudy. Now, when we talk about the rain. So here rainy, we have two different parent nodes for the rains, windy and cloudy, right? So for windy and cloudy, both features are nothing but this rain depends on windy and cloudy. So anything happens in windy and cloudy, that will affect rains. So that's why we have taken windy and cloudy here in the CPT table, while you write CPT for rains, because rain depends on windy and cloudy. So what are the combinations we have? Both are true, true, false, false, true, and false, false. And we have written separate probability for raining depends on this windy and cloudy state. Similarly, for wet grass we have one parent node, that is rain, a direct parent node. This windy and cloudy or indirect parents of wet grass, but we will consider only the direct parent class. It is rains for wet grass. So I will take rain here. So R is written here. We have true and false, and for probability of W we have given value for true and false. And similarly here we have takeoff from work, for which rain is the dependent variable. So we have taken rain here in the CPT table, and probability of takeoff is, we have 0.74 true and 0.01 false. So this is how a CPT table will be drawn for each and every features. So now the task is you have to find the probability of having a wet grass. So now probability of having a wet grass, how can we write this? Probability of wet grass, this wet grass depends on actually rain as per the CPT table. So given R, it may rain or it may not rain. We have both the conditions, rain equals true as well as rain equals false. So the probability of rain less, and we have probability of wet grass provided negation of R, right? Or we can even write it as negation of R into probability of negation of R. Now what is the value of wet grass given R? So we have R equals to, what is the net grass, the value here, 0.9. Let me take it as 0.9 into, and here we have probability of R. So we doesn't have probability of R directly, since probability R is dependent on W and C. So there needs some kind of calculations which we keep it there like this. We'll come to this later. And probability of wet given non-rainy, rain equals false. So rain equals false, so probability is 0.05. So let me take it as 0.05 into P of R negation. So here non-rainy is also dependent on W and C. We doesn't have the direct value of the probability. Here, since it depends on W and C, so we have to do it separately. Now we have to find P of R and P of negation of R, so that we can find the right value of probability of wet grass. So let us take with P of R. If we found P of R, then P of negation R is nothing but 1 minus P of R. So let us first find P of R. Probability of raining, it depends on wind and cloud, in which we have 4 states, right? So I'll write all the states here. So this is wind, cloudy, into probability of wind and cloud plus, then we will take with the probability of rain, wind false, cloud 2, into probability of wind false, cloud, plus probability of R given wind, cloud is, let me take it as negation, into, then again probability of, we have wind and negation of cloudy, plus probability of both are in false condition, into probability of negation of W and negation of C. Right. Now I have all the states values. Now let me talk with this R, W, comma C. We take R, W, comma C. So W is true, C is true. What is the probability? It is 0.95. So we can take 0.95 into, and here the probability of WC. W is true, C is true. When we take probability of W is true, here we have the value. probability of C equals true value is here. So we can take 0.001 and 0.002. That value should be written here. 0.001 into 0.002. Right, here we have taken rainy given W comma C. That's why we have referred here, right, probability of rainy given W and C. But when it comes here, we have taken probability of windy into probability of cloudy. It doesn't include a rainy condition. So directly we will be taking windy and cloudy probability table value. And next we will go with this probability of rain, wind, non-windy, cloud. Windy false. So here wind false, cloudy equals true. It is 0.29. So let me take 0.29 into probability of wind false and cloud true into wind false and cloudy equals true. So it is 1 minus 0.001. So what is the value we can take? 0.999. We can take 0.999 into 0.002 and plus probability of rain, wind, cloud false. Wind true, cloud false. What is the probability of rain? 0.95. So we'll take 0.95 into, we can take probability of W and probability of false condition for cloudy. Probability of windy equals to is 0.001. So we can take 0.001 into, here probability of C false. So probability of C false is 1 minus 0.002. 0.998 plus, and what is the last value we should take? It is probability of R given wind false, cloud false. We will take wind false and cloud false 0.001. So you can take 0.001 into, what is this, probability of negation wind and negation C. W false. W false is 1 minus 001. It is 0.0999 into, and what is this last one? P of C negation. So C is false, 1 minus 0.002, that is 0.998. So if I calculate this, then I'll get the value as 0. So if I calculate this, I'll get the value 0.002 252. So this is the value which I get while I solve the problem. So P of R is nothing but 0.00252. So how I can get is P of R negation, then 1 minus 0.00252. Alright. So this is how you have to find the P of R and P of negation of R value. So now after finding this value, we have to substitute this over there. So let me substitute the value here. Probability of wet grass is nothing but we have here, right? This is where we have to substitute P of R and P of R dash 0.9, 0.9, 0.9 into, and what is the value of P of R? 0.00252 less, and here we have 0.5 into P of R dash, 0.5 into P of R dash is nothing but 0.99744. This is the case. After calculating this, we will get 0.0521. So probability of wet is nothing but it is 0.0521. So this is how you have to find the probability of any given scenario or case using the CPT table for Bayesian belief networks. So here in Bayesian belief networks, for each and every feature you will be calculating the probability of the dependent variables, and that should be multiplied together in order to get the probability of the particular state. So that's all. Thank you.